Hey guys, this is going to be section 4.3 for Algebra 1, and let's just jump right in it. So continuing the chapter 4, all this whole chapter has been about has been writing equations of lines. Now, our lines are going to come from being parallel to another line or perpendicular to another line. So when you are parallel to a line, what that means is when lines are parallel, they'll never intersect. But that means something beyond that. It means something a lot more to us. If they're never going to intersect, they will always have the same slope. So if I can figure out the other line's slope, I would then know my slope because we have to be equal. Okay? So the first thing we're going to do is just check out parallel lines. So we got three lines here. We're going to see which ones are parallel. So I just said lines that are parallel have the same slope. These may look parallel, but I can't be sure. I can never be sure until I actually go through and see what their slopes are. By now, you should be able to know how to find the slope of any line, whether I write it algebraically, whether I draw a picture of it like this on a graph, or whether you're just given 2 points. So you should know slope formula. You should know how to find slope if I give you an equation of a line, and then you should be able to find it by counting rise over run. Counting rise over run is by far the easiest, so that's what I'm going to do. We've got lines A, B, and C. So I'm just going to count the slope for line A. Down 1, over 1, 2, 3, 4, 5. The slope for line A equaled negative 1/5. The slope for line B. Down 1, over 1, 2, 3, 4. The slope for line B, negative 1/4. For line C, down 1, over 1, 2, 3, 4, 5. So when you look at the picture, it does look like all three of these lines could be parallel. But when we look closely at the data, no, B is actually not parallel. A and C are parallel, but not B, because A and C have equal slopes. So which lines are parallel? Lines A and C are parallel because, sorry for the shorthand, because they have equal slopes. Okay? So now let's use that information. We know how to find if lines are parallel, and we know now that if they have equal slopes, they're parallel. Well, now we can use that to write equations of lines. So in example 2, we have to write the equation of a line that passes through the point 5, negative 4. Well, if we're parallel to y equals 2x plus 3, you should remember by now this is already in a form. If it's solved for y, this is in slope-intercept form, meaning this is my slope, this is my y-intercept. Well, if I want to be parallel to this line, I know my slope must equal their slope. Therefore, if their slope is 2, my slope is 2. And if we go back to the notes I gave you a while ago about how to ever write the equation of a line, the first thing you must do is find your slope. Their slope is 2. My slope is 2. Second, and this isn't always, but this is typical, plug M and 1 point into point slope form. So now I'm just coming in, point slope form of line, you should have it memorized, y minus y1 equals m outside of x minus x1. So we have our slope, and look, they told us what point we want to go through. We want to go through the point 5, comma, negative 4. That means our m is 2, our y1 and x1 come from the point. So y minus negative 4 equals 2 outside of x minus 5. Now we're just cleaning up. Minus a negative becomes a positive. And let's do our distribution and solve. Y plus 4 equals 2x minus 10. Final step, subtract 4 from both sides. And your final answer, let me see if I can get myself a little bit more room here. Your final answer is y equals 2x minus 14. And like I said, I don't always show it on here, but go to Desmos, graph this line in, and graph the original line. They should be parallel, which we know they will because they have equal slopes, but then this line should also go through the point 5, negative 4. Okay? So again, when you're writing equations of a line, 3 steps. First, find your slope. Second, plug your slope in one point into point slope form. Third, solve for slope intercept form, which is y equals mx plus b, and you're done. So here is your final answer for example 2. Thank you very much. Now we're going to move on to finding equations of lines with perpendicular lines.